Hi, everyone. My name is Chris Dufresne. I'm the Director of Research and Actuarial Services at the NAIC. And as many of you know, a few years ago, we started an NAIC rate model review group, and we're up to 5 employees now. They're all actuaries and data scientists, and they're available for those states that have signed an agreement with the NAIC to hold things confidential and everything else. We'll talk a little bit about all the products that we have through that team. And we're also working on education and hoping that today we bring you some basic education about what's happening in the rate model review space. For those of you that are in market conduct, I know you probably are watching how things are transpiring, and we're looking at models and third-party models beyond rate models. So I think all of us probably need to get up to speed on what GLMs are. So to my left here, I have Dorothy Andrews, who's our senior behavioral scientist, actuary, something like that, she'll tell you later. And then Roberto Perez, who is our actuary, rate modeling actuary and data scientist. They're 2 experts that know GLMs inside and out, and I hope you enjoy their presentation today.
Thank you, Chris. So first, we're going to talk a little bit about the history of GLMs, and then we're going to, like Chris mentioned, go through our products and our educational resources that we offer for you to use. Before I get into the history of GLMs, I want to quickly go through the history of insurance regulation, especially in the U.S. So before insurance came to the U.S., we have to go back about 4,000 years ago. That was the origins of insurance as we know it, at least a semblance of it, in the Code of Hammurabi. And I was in France a few weeks ago, and I went to the Louvre Museum. And I found out that they had the Code of Hammurabi there, and I tried for like half an hour, and I could never find it, so I'm pretty bummed about that. But that outlines the first instance of insurance being referenced as it relates to ships and cargo and using it as collateral for loans. So anyway, fast forward a few thousand years after that, in Europe in the 1600s, actually a little before that, insurance started developing more as it relates to ships and insurance for ships in the 1600s. Some fire insurance companies started, and then until about 100 years after that, the first insurance company was started in the U.S. And that was actually started by Ben Franklin, and I believe the name was the Philadelphia Contributorship. That was in 1752. 100 years after that, the first insurance commissioner in New Hampshire came to be. In 1869, we had Paul versus Virginia, in which the U.S. Supreme Court ruled that the sale and issuance of insurance is not interstate commerce and upheld the right of states to regulate insurance. 2 years after that, the NAIC was formed, which is the association that's organizing this insurance summit for you this few days here, and for which we work for. And that includes all 50 states of the U.S., D.C., and 5 territories, Guam, American Samoa, Northern Mariana Islands, the Virgin Islands, and my hometown of Puerto Rico, of course. And then in 1945, the state authority was ratified. So enough of general history. Let's go now to what everyone is here and excited for, right? GLMs and modeling. So data has always been very important for the insurance industry, and there has always been ways to analyze the information that we have available to try to predict what will happen in the future. That's a cornerstone of our industry. Initially, the methods used to do that were rudimentary, to describe them. For example, univariate methods, just looking at the data, see what happened for a specific cohort, and try to derive conclusions based on that. Then in the 1960s, we started getting a little more advanced. Minimum bias procedures started being used around that time. Fast forward a few years, then GLMs became the most used methodology in the 1990s. and have stayed that way until the present. And in the past few years, we have seen some additional methodologies start to be implemented as well, although GLMs are still by far the most commonly used methods for insurance rating. Okay, go back here. There you go. So GLMs themselves, although they were started to be used in the industry in the 90s, were introduced in 1972. And then in 1988, the equivalency between the minimum bias procedures that were used in insurance and GLMs was established, essentially meaning that minimum bias procedures are a special case of GLMs. Under some circumstances, the results that you get using minimum bias and GLMs are exactly the same. Now, of course, GLMs allow more flexibility to model data in different ways, and most importantly, they allow us to better understand the information, the output that's being provided by them. They allow for statistical tests to see if a variable is important, et cetera, that we don't really get when using minimum bias procedures. So they were preferred, and they have stayed that way until the present. A paper using GLM for rainmaking was specifically published in 1999. But since the 1990s, like I mentioned earlier, GLMs have been the cornerstone of the industry. Okay, so I'm just gonna go through a little theory, nothing too complicated, just to give you an idea of what a GLM is. So basically, GLMs allow us to model the relationship between a variable to be predicted, which we call the target variable, and one or more explanatory variables, which we call the predictors. In insurance, usually our target variable is pure premium or loss ratio, or if we do frequency severity modeling separately, then we use a GLM to predict claim frequency, another GLM to predict claim severity, and then we combine them to get the pure premium, and then we use that to determine rates. And our explanatory variables or predictors are the characteristics of the insurers that we use to differentiate between them. So for example, for auto insurance, a predictor can be the age of the driver, the type of car that they drive, some telematics information. That can be the predictor variables that we're using within the GLM to then predict their risk potential. The dependent variable that we mentioned, which we call the target variable, is modeled as a random variable that assumes a distribution from the exponential family. And all you need to know here is that the exponential family can be parameterized in terms of two parameters, the mean of the distribution and a dispersion parameter. And some examples of the exponential family of distributions that are commonly used are normal, Poisson, gamma, binomial, Tweedy. Usually we use Tweedy when we're modeling pure premium or loss ratio. We're modeling severity and frequency separately. We use gamma for severity, Poisson for frequency. In a GLM, the relationship between the model predictions and the predictors is given by the formula we can see here. A G of mu, which is the mean of the target, equals the coefficients times the variables that we're using. The right side of this equation is known as the linear predictor, and the G is known as the link function. And that just allows us more flexibility when using the GLM to model. Like I mentioned, GLMs are the main methodology used. However, in the past few years, we have seen additional methodologies being implemented. Here's this neat graph that outlines different modeling techniques. In the bottom right here, we can see supervised learning techniques, such as random forest, neural networks, and gradient boosting trees, which are being used more frequently now. Okay. We at the NAIC Model Review team have several educational resources that you can use to learn more about these techniques and how they're used in the industry. Here, we're listing a few of them, and we're going to go into more detail on where they are, what you can find in them, and how you can access and use the information that is available in those educational resources. So we do book clubs. We have a white paper with several appendices for different modeling techniques. We're also going to briefly talk about the AI ML surveys that we have performed to better understand the usage of AI ML in the industry. We also have our PNC shared model database, which we maintain with the model reviews that we have done, and we also make it available for states to upload any reviews that they have performed, so other states can use that in their reviews. And mainly, we're also going to talk about a GLM video series that we are working on to help regulators understand GLMs and how to effectively evaluate them and assess them. Okay, so the book clubs are roughly a monthly webinar that we organize on topics of interest to regulators. And sometimes we present on a certain topic, sometimes we get people from the industry to present on something that could be of interest to regulators. For example, we had telematics, book clubs. We talk about GLM model documentation in filings, non-GLM model documentation in filings. We've had the American Academy of Actuaries talk on interesting topics relating to insurance regulation, as well as additional modeling techniques and the theory behind them. From 2023 to the present, all the book clubs that we have hosted can be accessed on the NAIC CASTAF website. The ones before 2023 are archived in the Center for Insurance Policy Research, and we have the links for both of them here. They're all accessible to anyone. All right, another resource that I wanted to highlight is the Regulatory Review of Predictive Models white paper. And this was initially created with the main intent of establishing best practices when reviewing and evaluating predictive models by state regulators. The initial Regulatory Review of Predictive Models white paper was based on GLMs, although now we have prepared several appendices such as regularized GLMs, GAMs, and random forests. So we have updated the information in the white paper to address the different necessities that we have when reviewing those other techniques. The NAIC AI ML surveys were created to better understand the usage of AI and ML in the industry. As of right now, we have done 3 AA ML surveys. The first one was on private passenger auto, which was issued in December 2022. Then we had the home insurance survey in August 2023. And the final one was the life insurance survey, which Dorothy worked a lot on, and that was issued in December 2023. The goals of these surveys were, 1, to gain a better understanding of the insurance industry use of governance and AI. 2, seek information that could aid in the development and guidance or potential regulatory framework to support the insurance industry's use of AI, and to inform regulators as to the current and planned business practices of companies. So you can access these surveys online here. I'm just showing a brief slide showing what kind of information you can find on one. I'm taking this from the private passenger auto. And this shows what rating data elements are most commonly used by companies when pricing for auto. And here we can see that vehicle-specific data, as expected, right, is commonly used. Rating data element, loss experience, consumer, other type of score, insurance score, etc. So this and much more information can be accessed on the survey reports that we have prepared for these 3 surveys. And the last thing that we're going to talk about, and Dorothy is going to discuss it in much more detail, is our review of GLM video series, which is an on-demand GLM review video series covering important topics that we need to check when reviewing a GLM. And this includes introduction, high-level summaries, data prep, general data commentary by the company, addressing the data relevance commentary provided, any collinearity and how that could affect the GLM model and the output, the validation of the model that is intended to be used, as well as the implementation of the results. So having said that, I'm going to leave it with Dorothy, who's going to talk about this in significantly more detail.
Okay. Well, good morning, everyone. As Roberto said, I'm going to talk you through some highlights of some of the training videos that we've developed. Our goal with these videos is to provide some basic training on technical models so you are more comfortable reviewing them and asking questions about aspects of these models you don't understand. So every good model review starts with understanding the data. This requires a good data dictionary. The NAIC model review team has developed standards for a good data dictionary, and we judge company data dictionaries by this standard. So this module focuses on the data dictionary. So why is a data dictionary an essential tool? Well, you probably guessed why. The number one reason is you cannot fully understand a model if you don't understand its basic ingredient, the data. The data definitions are the vocabulary of the model and must be understood to ensure sound model construction, sound model interpretation, and sound model implementation. My alter ego, Darcy, points out the data dictionary is the linkage between the model and the human understanding of the goals and purpose of the model. It is an essential part of the governance framework for the model and vital for an independent review of the model. Other data dictionary, often the data dictionary is an afterthought in modeling, but this must change. The NAIC model review team conducts thorough examinations of company data dictionaries and looks for weaknesses in their structure. It is difficult, particularly concerning if a data dictionary has one vocabulary, but the model reflects a very different or cryptic vocabulary, and there is no linkage between the two. This makes it difficult to draw conclusions about model parameter estimates if you don't understand what the model parameter estimates mean. For example, if the data dictionary has a variable called year, but the model reflects it as a variable called V1, and there is no linkage between the two in the data dictionary, you'll have no way of understanding the significance of the parameter estimates. As with any language, understanding what words means is very important. So what does the NAIC model review team think is a good data dictionary? What should be in there? I'm so glad you asked. The elements the NAIC model review team thinks are critical to include in a good data dictionary are the variable name as it appears in the input model data, the variable names matching other filing exhibits, the data source, whether it's internal or external, what type of data an element is it discrete, continuous, categorical, or logical? How is it treated? Is it a model variable, a control variable, an offset, or a target? What possible values are reflected on that variable? And what are the variable rationales? So I particularly like this slide. Those of you who have a mathematical background will see the funniness in this slide. I got to stop laughing. Okay. The NAIC Casualty Actuarial and Statistical Task Force Regulatory Review of Predictive Models white paper recommends rate filing reviewers to obtain a rational explanation for why an increase in each predictor variable should increase or decrease frequency, severity, loss costs, expenses, or any element or characteristic being predicted. The explanation should go beyond demonstrating correlation. Considering possible causation may be relevant, but proving causation is neither practical nor expected. If no rational explanation can be provided, greater scrutiny may be appropriate. For example, the regulator should look for unfamiliar predictive variables, and if found, the regulator should seek to understand the connection that variable has to increasing or decreasing the target variable. A rational explanation is defined in the white paper as a plausible narrative connecting the variable and/or treatment in question with real-world circumstances or behaviors that contribute to the risk of insurance loss in a manner that is readily understandable to a consumer or other educated layperson. A rational explanation does not require strict proof of causality, but should establish a sufficient degree of confidence that the variable and/or treatment selected are not obscure, irrelevant, or arbitrary. The NAIC white paper goes on to say a rational explanation can assist the regulator in explaining an approved rating treatment if challenged by a consumer, legislator, or the media. Furthermore, a rational explanation can increase the regulator's confidence that a statistical correlation identified by the insurer is not spurious, temporary, or limited to the specific data sets analyzed by the insurer. So, as with all of our videos, we like to have a review at the end to see how much you've learned throughout the course of the module. And I have no doubt when you go through one of these modules that you'll pass with flying colors. We also do allow you to go back into the previous slides if a question seems challenging so that you can find the appropriate answer. And as always, you know, the NAIC model review team is available to answer any additional questions. So Roberto mentioned collinearity earlier. Collinearity refers to the correlation between two or more variables. Multicollinearity means the variables on one variable can be determined from the values on another variable. So for example, all the values on variable X could be twice the values of variable Y. These issues can make parameter estimates sensitive to changes in the model and inflate the variance and standard errors of parameter estimates, adversely impacting p-values. So the important definitions for every module are defined. And for this module, the important definitions are correlation, collinearity, and multicollinearity. There are two types of correlation coefficients that we typically look at depending on the variable type. If two variables are continuous, Pearson correlation coefficients are appropriate. Kramer's V correlation coefficients are appropriate if at least one variable is categorical. The tables that you see reflect some commonly used rules of thumb for gauging the magnitude of a correlation coefficient. For Pearson, the benchmark for a high correlation is 0.7, and it's 0.6 for Kramer's V. Additional interrogation of the model is essential when correlations exceed these benchmarks, because the concern is highly correlated variables can lead to unstable correlation coefficients. So a correlation matrix is typically a square grid with variable names along the columns and the same variable names in the same order across the rows. Each cell contains the correlation coefficient for the variables forming that intersection. It is really important to have companies provide a separate correlation matrix for each model. When companies attempt to provide one enormous matrix for all variables across all models, that can be time-consuming to analyze. The company, in my view, is really responsible for making your review as easy as possible. So the technical model assumptions module aims to train users on the modeling assumptions that are important to request, what they mean, and whether the company employed and provided the appropriate assumptions. The regression equation helps us understand whether or not the company formulated the model correctly. We are looking to understand what the link function is the company is using. We mostly see log link functions or the identity functions. The link function also helps us understand whether or not the distribution is appropriate for the modeling assumptions chosen. Okay. This chart is helpful for understanding modeling types and their appropriate assumptions. It shows the distributions that are typically used for modeling frequency, severity, pure premium, and loss costs. It also includes how the target variables should be defined. For example, for a frequency model, the target variable should be defined as claim count divided by exposures. For severity, the target variable should be loss dollars divided by claim count. For pure premium, the target variable should be loss dollars divided by exposures. And finally, for loss ratio, the target variable should be loss dollars divided by earned premium. If you look at the last column, you'll notice that the weights are appropriately defined as the denominator for each of the target variables. Residual plots. A residual plot is a scatter plot that displays the residuals on the vertical axis and the independent variable on the horizontal axis. Residual plots help us determine whether a linear model is appropriate in modeling the given data. Residuals are the difference or misprediction between the actual values and the values predicted by the model. In this way, a residual plot shows how the actual data points deviate from the modeled or predicted data points. If the residuals are randomly scattered around the residual equal to 0, it means that the linear model approximates the data points well without favoring certain inputs. In such a case, we conclude that a linear model is appropriate. If the residuals show a curve pattern, it indicates that a linear model captures the trend of some data points better than that of others. In such a case, we should consider using a model other than a linear model. In the two plots that you see on the screen, one is a histogram and one is a QQ plot. We expect the residuals to follow a normally shaped distribution. So we take all of those individual differences and we bucket them and we create histograms, and we hope that histogram can be approximated by a bell-shaped or normal distribution. On a QQ plot, we expect if the model truly is reflecting something that's normally distributed, we would expect to see a basic quantile, those points to lie on that straight line. When we see deviations, that can give us some indication that some model assumptions are being violated. Okay. So one of the most important pieces of information a company can provide from the GLM is the output that it produces. This output helps us understand how the GLM was fit to the actual data by the model. It contains a lot of valuable pieces of information. If you think about it, we know what the input is, and we know what the output is. With the GLM, we're trying to figure out how to make the input predict the output. This is the basic problem-solving approach that we used in algebra. Remember algebra? Everybody? Good memories of algebra? I hope so. Oh, good. I see someone shaking her head. Yes. Sometimes when I bring up algebra, people leave the room. So, the beta coefficients show us three things. One is the magnitude of the impact they will have. The second is the direction of the impact they will have. And finally, the third is their relationship to indicated factors in multiplicative models. Negative beta coefficients imply discounts, while positive beta coefficients imply surcharges. So while we like to think of math as logical and axiomatic, it can produce nonsensical results for lots of reasons. Therefore, it is extremely important to evaluate the reasonableness of the results. It is not unusual that younger and older drivers would be riskier than others. However, those 61 and over are not as risky as younger drivers. Well, what might explain this? Anyone have a guess? I have the answer here. So research has shown that they tend to drive less and they tend to drive closer to home. So that could be one explanation, but I'm sure there's probably other reasons as well. Rational explanations can be very important in helping you understand why a company included a variable in its model. However, some company rational explanations are not all that rational. Some may even be illogical and inappropriate. For example, a rational explanation that only references statistical relationships to p-values is not really helpful. Don't just tell me because it had a significant p-value. That's not helpful. The explanation really should point to something that is causal in the relationship between the two variables, the dependent and the independent variable. So I hope this high-level primer was useful, and I hope you're all now really excited to go and sign out all of our GLM videos. We promise we reflect some sense of humor in them. And I'll turn it back over to Roberto to conclude.
Yeah, no, we're going to open it up for questions, but just to recap, as you saw on Dorothy's section of the presentation, we look at the data dictionary, or part of the data dictionary video series, collinearity, model output. So what we are creating here is a set of short video series that you can reference when you need to understand a specific portion of that model review process. You can easily access it, look at a 10-minute video, and be able to evaluate the model after using the information provided in them. And we just provided some excerpts of the videos that we have prepared so far, and we are continuing to work on additional areas that then you can use in your reviews.
And they're good for training new staff.
Yeah.
I want to add that as you look through these modules, they're written very simplistically, we hope anyway, for your rate model review team who are not actuaries. So that's our target audience here for these GLM modules. And they're written in such a way that will define every variable, will help you find such information within the rate model. We will help you analyze that information in the rate model, and we will help you to determine what kind of decision you might want to make in that rate model. So it will be very helpful, very hands-on for your staff, and I hope you take a look at that beginning of next year. Let me ask you a question about rational explanation. You gave a really good example of age. What's something, let's say like someone drives a red car, what would be a plausible rational explanation for something like that?
For their increased risk. Someone could be more inclined. Well, that's the importance of having the rational explanations. Because if we just, like Dorothy mentioned, solely rely on something being statistically significant, then you may get that just by random chance and not necessarily because there is causal relationship between that and losses. In the case of the red car, that's something that you could potentially see it on the data, but doesn't really mean that you should be rating on that, at least in my opinion. And again, it's possible that there's a reason, and that's why we're asking for this, because maybe the company can, or thought of something that we haven't or other companies haven't, and that's fair. So if they can support the usage of that in a way that makes sense and it satisfies everything that we're looking for in a rating variable, then that'll be okay. But something that just happens to be significant because you got a p-value less than 0.05 and you cannot support in any other way, we don't really believe is acceptable, because it could just be by random chance. And there's a lot of theory regarding how that can happen. Something like what we call p-hacking. If you tried 100 different variables, just by random chance, you'll get some that will show low p-values. So it doesn't mean that they actually show a real relationship with the characteristic and losses.
Yeah, and the other thing is, if you think someone is giving you rational explanations that don't really make any sense, you can always go back and say, well, can you please provide me with some academic support or research for that relationship? Because, as both Chris and Roberto alluded to, sometimes we see a lot of rational explanations and, we sit there kind of scratching our heads, well, how'd they come up with that one? And, if they came up with it, I mean, they really should have some real basis. It's not just what they saw in their data set, because one data set can really give a false illusion of what's going on. You need to do lots and lots of repeated trials to actually see if phenomenon is real. So, just politely ask, please provide some academic support. As far as red cars, I know some people used to, there was a time where this red car variable was like the thing, like lots of sports cars are red. I don't know if that's true anymore, but, it shouldn't be a situation where there could be a lurking variable that's more explanatory for the relationship than the one that you're seeing.
Yeah, and just to highlight the sports car thing, right? And that's true, like a lot of sports cars are red, right? But that doesn't mean that rating based on color makes sense.
That's right.
Because if you don't have a sports car, then it wouldn't make that, if that's a reason, it wouldn't make sense.
Right.
So there's other variables that you could use, perhaps a type of car, that could explain all that information, and then that can be explained, instead of just saying that there's a relationship, there's a correlation between these two variables. Okay.
Does anybody have any questions?
Yeah.
We have our friendly microphone coming around here. Phil, it might take you a...
Hi, thank you for producing these videos. It sounds like it's going to be great help for the departments. My question is, from what I've heard in the presentation so far, it sounds like the videos will mostly be focusing on the what should I say, the technical side of evaluating the models or something. And I guess my question is, often one of the things that we as regulators have to struggle with is quality of data sets. And I'm wondering if anything in the videos or if there's any modules that might be planned on addressing, topics that are somewhat outside of just, here's how you evaluate the GLM itself. So.
Do you want to answer?
We can certainly add a video like that. But I'm also working on a video on how to look for unfairly discriminatory trends and variables. So that's part of data quality. But I think you're talking larger, like how do you go about doing this exploratory data analysis to see, how much data, like what kinds of class imbalance there might be in the data, and other types of biases that would sort of help you understand if the results are going to be biased. Would that be a fair statement? Yeah, we certainly have enough material ready to put something together like that. We can add that to the list.
What are some of the issues like survey data?
Yeah, so, in some of the stuff that I look at in terms of data, I see things like tomorrow I'm giving another presentation and I'll be talking about data issues with like third-party vendors. And some of the things that I've seen is they'll advertise that, for example, they represent 180 million households in the data. Well, there aren't that many households in the U.S., according to FRED, the Federal Reserve economic data. There aren't that many households. You have other data sets that have like these weird classifications for people, like they'll call them like urban fringe or remote America. They have like all these weird names, which definitely sort of speak to this data could probably be biased. And there was a company that tried to use that data in a state, and after looking at some of the classifications, it was labeling people as, especially the urban fringe was really disturbing. They told the company they couldn't use it. So it's stuff like that. If it's some of these third-party vendors, it's based on survey data that is based solely on like college students. Well, that's not a very representative population. So you have issues like that you want to look at. And then the other thing is when you're looking at different groups of people, there should always be as many positive outcomes as negative outcomes for a particular group in the data. Otherwise, you can bias your model results towards, if you have more negative outcomes, towards more negative outcomes. And that can lead to generalizations about groups that are not appropriate and, give them some unfair pricing in your model. So there's a lot of things that, we can look at in terms of just the input data. How do we assess the input data for A quality? How much garbage was in the data? People don't think about imputation as a way of biasing data, but it is a way of filling in the blanks the same way we do cognitively when there's missing information. And these imputation methods do create bias in your data, even though they sound logical. It sounds pretty harmless. Oh, well, let's just use the mean if something is missing. It sounds harmless, but it does actually distort the distribution on that variable. Other methods like using randomization to fill in the blanks. Some people say, well, at least that will preserve like the variance structure on that variable. But it's things like that, I think, we don't think about that we use because it's based on math. I'm like, oh, well, it's probably okay because it's based on math, but it actually does create some additional forms of bias in the data. So I think that's a really good suggestion to have a data quality kind of modules to help people understand what kinds of questions should you be asking about the input data. And that will, how the company answers those questions before they even run the model will start to explain to you how the model outputs could likely be biased. So.
Yeah, and I just wanted to add that we do have a module that's going to touch on third-party vendors, and we are thinking of also discussing variables that are used, but that's something we can definitely expand on more. And I also wanted to add that in addition to all the technical aspects of model review, we also have modules on the other side, evaluating the model output, not on the data, but at the end, and how to interpret what the company's doing in that regard.
Yeah, and just like Phil suggested this module on data quality, if you guys have ideas of things that you want to see, definitely tell us, because we're kind of sometimes in our little cocoon here, thinking, oh, well, we want to investigate this. Well, it's not necessarily what we want to investigate, it's really what you want us to investigate and develop modules for. So definitely let us know if there's things that you would like to see us do in terms of these modules.
Hi, Sandra Darby from Maine. I think model drift would be another good topic. So for a video series for like after the model's implemented and what happens 1 or 2 years down the road, and how to evaluate what you would ask a company about their GLM that you approved 2 years ago. I also was curious if any of these videos had like continuing education credits for maybe the NEIC professionalism program, just out of curiosity, for folks that maybe, for me, I would use them for model review, like I'd watch the video and do my work, but maybe for folks that just are interested in the topic. And I know there's CE credits for other things that they can see on the NEIC website.
We haven't yet explored that, but we can.
We're taking notes.
Yeah.
One other thought is possibly just a high-level video for maybe commissioner, superintendent, or just higher-level folks who maybe don't understand the nitty-gritty of a GLM, but something that would be basic enough for them when we're speaking to them, they kind of understand what we're talking about.
So in our last 2 minutes, is there something that you have seen in rate models, without giving away company names or anything like that, that's some of your main findings, other than the company did not file enough information for us to tell?
Well, we've definitely seen a lot of concerning stuff in our reviews. I think as it relates to the variables used, that's always something where we find stuff there that requires additional judgment because the company has not supported that. I also think in terms of the modeling techniques used, when GLMs are not used and some of these more advanced techniques are implemented, we have found some issues in that implementation. Both in the implementation itself, just the theory behind what the company is trying to do there, as well as just mistakes when they understand how the technique is intended to work, but in our review of examples of how they're doing it, we have found that they are not doing the calculations or the process how they intended it to be done. And those are the things that can really break a model and the output that you're getting, and can affect the people that the model is being used on. So I just wanted to highlight that. There's definitely a lot of other things that we have seen, but I think the most concerning are those when something that the company does not intend to happen happens.
Yeah, they just, they don't always strictly follow the form of the model, and they're just using it to pull off, a coefficient that they want to stick someplace else. So it's not strict adherence to the theory, and I think that can be problematic, especially if people start getting hurt.
Thank you all for joining us today. We really appreciate it. You can give us a call anytime you have a question. So thanks, everyone.